Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about another example of elementary function, which is the even function and odd function. Okay, so the function is called an even function if this equation is satisfied for every x in its domain. An example of this is going to be given later on, but for the time being, I'm just going to talk about the geometrical aspect of it, where when you have an even function, the graph will be symmetric with respect to y-axis. So this is your y-axis, this is the y-axis, and if let's say you have this part of the graph over here, so this is part of the graph over here. Basically what it means by symmetric with respect to y-axis is that you may have, for example, you can have this point here will be reflected to this part of the graph. Okay, you'll be reflected at this part, and for example this point on this line, on this green line here, will be reflected with the same distance on this part here, which is going to be at this point. And for example this one will also be reflected with the same distance at this point, and here will be at 0, and therefore you can easily have another graph on this part, which is just a reflection of this part here. So this is the graph here. So this is symmetric with respect to y-axis. Now we are going to look at the idea of odd function. Okay, so when the function is odd, it has to satisfy this equation here for every x in its domain, and geometrically the graph will be symmetric about the origin. Okay, so in other words, when you rotate the graph at 180 degrees about the origin, it won't change the look of the function at all. So I'm just going to give a quick example of quick illustration of that particular sentence. Okay, so let's say that first we have this graph here. Okay, so this is the graph that you have. Okay, next let's say you have this this point here to consider. So this is the point to consider, and it says that it should be symmetric about the origin. So if you consider constructing a line having this particular line, I'm sorry, it does look a bit weird. Let me just correct the line. Okay, let me just do it one more time once again. Okay, so let's say that this is the graph that we have. Yeah, this part. And for example, if you have this particular point, okay, and it says that it will be symmetric about the origin, so you can imagine having a line constructed here. Okay, just this line constructed here. So you can imagine that this point rotated at 180 degrees. So this point will be going in this direction, and it will be mapped at this point. Yeah, so 180 degrees. So this point is making a turn, is rotating at 180 degrees, and it will be reflected at this point here. Now if you have, let's say, if you consider another point on this graph, let's say at this point. So if I sketch a line from this point to the origin, Okay, so basically this point here, when rotated about 180 degrees, at 180 degrees, then it will be mapped at this particular point. Okay, so basically that's the idea. And so if let's say you have this graph on this side, you will have the same look of this graph on this part here. So so that is basically saying that rotating the graph at 180 degrees about the origin won't change the look of the function. Okay, right. Again, we're going to pay a closer attention to this part. Okay, so now we're going to pay closer attention to this part, and we're going to apply this information in order to solve example 1.7. So in this example, you have to determine whether each of the following function is even, odd, or neither even nor odd. Okay, so we're going to start with question A. We have fx is equal to x to the power of 5 plus x, and in order to know whether it's even or odd, you have to see what happens when you introduce negative x into the function. Is it equal to fx? If it is, then it is even function. If it isn't, if you get negative fx, then this is odd function. Okay, so now I'm going to introduce, we're going to substitute x with negative x. So now f negative x is equal to, so here you have to substitute x with negative x, so to the power of 5 plus negative x. And then you can go on and simplify the look of this function. And since the power here is odd number, the result is going to be negative x to the power of 5 minus x, and this can be written as negative x to the power of 5 plus x, and we know that x to the power of 5 plus x is fx, so negative fx. And therefore, based on what you have seen here, this is an example of an odd function. Okay, so therefore this is an odd function. Okay, right, next we're going to look at the second part, which is question B. So here we have gx is equal to 1 minus x to the power of 4, and now we are going to again introduce negative x. We're going to substitute this with negative x. So what happened when we substitute negative x? So we have 1 minus, so x here has to be substituted with negative x to the power of 4, and 1 minus, we know that if you have negative something and the power is an even number, then the result is going to be positive, so it's going to be x to the power of 4. And so this is 1 minus x to the power of 4 is actually just gx. So this is equal to gx. The result here is equal to gx. And based on the equation which you have seen here, the rule which you have seen in this page, we can say that therefore this is an example of an even function. So this is an even function. Alright, for question C, I think you can determine the answer yourself. Good luck with that. And I think that's all for now. Thank you very much for watching.